Hello everyone. Today we're going to be talking about solving exponential equations. So an exponential equation is basically any equation in which the variable is in the exponent. So for example, 5 is equal to 3 to the x. This is an exponential equation because my x, my variable, is in the exponent. And so something that's going to help us to solve these types of equation is the property of equality for exponential equations. And that tells us that if b is a positive real number other than 1, then b to the x equals b to the y if and only if x is equal to y. So for example, if 3 to the x is equal to 3 to the 7th, then x has to be 7. So in other words, if an equation has the same base, then the exponents must be equal to each other. So in this previous example, 3 to the x equals 3 to the 7th. The only way that statement is true is if our exponents are equal to each other. So that's why x has to be equal to 7. It can't equal 5 because 3 to the 5th does not equal 3 to the 7th. Can't be any other number except for 7. So let's use that fact to help us solve these first three equations. So number 1, I have 2 raised to the x plus x power is equal to 2 raised to the 4x. Here I see they both have the same base of 2. So since they have the same base, that means that my exponents have to be equal to each other. So that means that x plus 6 has to be equal to 4x. And now I have a typical equation that we can solve. So I'm going to solve for x, so I'm going to subtract x from both sides. And I get 6 is equal to 3x. And then divide both sides by 3. And I get that x is equal to 2. Okay, now let's look at this next one. This next one I have 27 raised to 3x power is equal to 81. This time I don't have the same base. My base for on the left-hand side is 27. The base on the right-hand side is 81. However, I can rewrite those numbers so that they do have the same base. For instance, for 27, I know I can rewrite that to be 3 cubed. And then my 81, I can rewrite that to be 3 to the 4th. And then we know from the power over power property that 3 to the 3rd to the 3x is the same thing as 3 to the 9x because I can multiply those exponents. And now I see that I have the same base of 3. So since I have the same base of 3, I can say, well, that means that my exponents are equal to each other. So that means that 9x is equal to 4. And if I divide both sides by 9, I get that x is equal to 4/9. Okay, let's look at one more. So here I have 100 to the x power is equal to 1/10 to the x minus 3. So at first I don't have the same base. However, I know that I can manipulate both of those to have the same base of 10. And to do that, I see that 100, I can rewrite that to be 10 squared raised to the x. And 1/10 is the same thing as 10 to the negative first power raised to the x minus 3. And now I'm going to use that power over power property. And so I'm going to multiply those exponents. So I get 10 raised to the 2x is equal to 10 raised to, if I multiply that negative 1 with x minus 3, I get negative x plus 3. And now I have the same base like I wanted. And so since I have the same base, I know for my property, that means that my exponents are equal to one another. So add x to both sides. And I get 3x is equal to 3. And then divide both sides by 3. And I get that x is equal to 1.